So hello guys, my name is Bibai and I'm gonna teach you today vector algebra, one of the most important mathematical systems which is used in physics regularly. Vector algebra is one of the important concepts that we need to master to run advanced problems. So let's go. So we're gonna start with vectors first, then we'll come to the algebra of vectors. So vectors represent vectors represent one of the most important mathematical systems. Vectors represent one of the most important mathematical systems. Now, what is a mathematical system? I underline this word mathematical systems. What is a mathematical system? So we're gonna learn what is mathematical system, what is it composed of, and then we will try to understand the perspective of the vector, that how it is useful for us to use this system in physics to solve higher equations or higher concepts. So what is a mathematical system? Let's define that first. Mathematical systems. So what is a mathematical system? It is a set of ingredients and it is a set of ingredients. What type of ingredients? It's not cooking ingredients. It's about uh, it is a set of ingredients and a rule book. It is a set of ingredients and rule book that dictates how the ingredients can interact. That dictates how the ingredients can interact. So mathematical systems are a set of ingredients and a rule book that dictates how the ingredients can interact. So this is how mathematical systems are formed. For example, if I take a system, for an example, geometry. Geometry is a mathematical system where there are lines, where there are points. They all can be related to each other to express each other. That's how a system is formed. Every formal system, every formal system is built on these four components. Every formal system that is existing or yet to be existing in the world is composed of four components. What are those four components? Let's see. Four components. First is undefined term. Every formal system consists undefined terms. Undefined terms. Let's explain undefined term. B most the most basic building blocks that we doesn't define. The most basic building blocks that we don't define, but simply accept. We don't define undefined terms, but simply accept. For example, points, lines, etc. etc. Points and lines is one of the undefined terms that we don't define, simply accept it. How can you define a point? A point is just a dot on a plane. How can you define it? What is a line? Line is composed of points. And point, simple. The points and lines both they interact with each other, which is the first of the definition of mathematical system. It is a set of ingredients and a rule book that dictates how the ingredients can interact. The second component is define terms. What is a defined term? Let's say concepts built out of undefined terms. Concepts built out of undefined terms. For example, a triangle, a square. These are all defined shapes and geometry. What is a triangle? A triangle has three sides, 3 points, three vertex with three lines. A triangle is composed of three lines and lines are composed of points. So you can see that triangles use lines as their building blocks and lines are undefined term. It means a triangle is composed of three lines and lines are composed of undefined terms, which makes our definition true. Concept built out of undefined term. Triangle is a concept which is made out of line and line is an undefined term. Then comes our third point, axiom. Axioms. The ground rules that we assume are true without needing a proof. The ground rules that we assume are true without needing proof. For example, the shortest distance between 2 points is a straight line. The shortest distance between between 2 points is a straight line. This is how axioms are built, the ground rules that we assume true without needing proof. For example, the social distance 2 points is a line. If I ask you to prove that statement, how can you prove? We just assume that it's true by our logic. We don't need such concepts to be proven, and those terms are considered axioms. And those things which are needed to be proved, opposite of axioms, are theories. Theories or theorem, whatever that you can say, theorems, yeah, theorems. New truths that are discovered by using logic to combine the axiom. New truths that are discovered by using logic to combine the axiom. Are discovered by using logic to combine axioms. So this is our first slide, which tells about mathematical system. It is a set of ingredients and a rule book that dictates how the ingredients can interact. So a mathematical system is a system in which components in which ingredients are there and they interact with each other, but with a rule. If we change the rule, everything changes, everything breaks. So there's always a rule book, there's always a law which you always need to follow. Every formal system is built on these four components: undefined terms, defined terms, axioms, and theorems. So without these four, no formal system can be formed. Any mathematical system, any formal system in the world which is currently existing or which can be discovered in near future is definitely composed of these four components: undefined term, a defined term, an axiom, and a theorem. The vector is also one of the most important mathematical systems which is used in modern day physics, which is used in modern day mathematics to ease our burden of solving high questions, high equations. So in this session we will learn about vectors. Right now we will just learn about vectors a little more, not right now algebra, because to learn vector algebra, you need to understand the most basic concepts of that vector and algebra. So we will first start with vector, then come to algebra, and combine both, we will learn vector algebra. Now from here, our chapter begins. Before that, we were talking about mathematical system, which is just an introduction to a vector. Our real introduction starts with this concept called quantities. Long ago, there were a lot of quantities in physics. So physicists and scientists come with an idea to classify quantities into two categories called scalar quantity and vector quantity. scalar quantities and vector quantities. So what are these quantities? Let's learn about them one by one. So scalar quantities, physical quantities, which only have magnitude, which only have magnitude. For example, if I want to say about scalar quantities, you can talk like speed, mass, density. These are all scalar quantities which just have magnitude, nothing else. And what are vector quantities? Physical quantities which have magnitude as well as direction, are called vector quantities. For example, velocity, force, volume, etc. etc. Actually, volume is not a vector quantity, I mistook that. Sorry. Instead of volume, we will write acceleration, just confirm vector quantity. Acceleration. Easy. So physical quantity which have only magnitude as scalar quantity and quantities which have magnitude as well as direction are called vector quantities, where there are examples given. Now we will solve some questions because scalar quantities and physical vector quantities are few of the things that we have already understood from our earlier classes. So I don't think we need to go more in depth about these things. Let's move on to questions. What these questions are? Questions are about that there are following measures. We have to classify whether they are scalar and vector. By solving these questions, we will also try to clarify these quantities more and understand a little bit in more depth. Let's go. Classify the following measures as scalars or vector. Our first question is 20-meter northwest. scalar quantity or vector quantity? Of course, it is a vector quantity. Why it is a vector quantity? It has magnitude 20 meter and direction, which is also given there, northwest. This is northwest and NW. Second question is 10 Newton. 10 Newton. What Newton? 10 Newton. It is also vector. Let me explain why. It is vector because Newton is SI unit of force, which is vector. Thus, it is vector quantity. Simple as that. Next question is 30 kilometers per hour. Kilometers per hour. What is 30 kilometers per hour? It is the SI unit of speed, and speed is scale. Then comes our next question, 50 meters per second towards north. It is a vector quantity because there's a magnitude as well as direction. Thus it is vector, and it is called as velocity. It is And last but not least is 10 to power minus 19 coulomb. This is a little bit more harder than previous four. But it's easy. It is scalar quantity because coulomb is the SI unit of charge, and charge is the scalar quantity. let's recap faster. Quantities can be divided into scalar quantities and vector quantities. Quantities which have magnitude or scalar and which have magnitude as well as direction or vector. We were given 5 questions about to classify whether they are scalar or vector. 20 meter northwest is vector because it has magnitude and as well as direction. 10 Newton. Newton is the SI unit of force and force is a vector quantity. Hence it's vector. 30 km per hour because it is scalar, no direction. 15 meter per second towards north. It has magnitude as well as direction. Thus it's vector. 10 to power minus 9 in coulomb. Because coulomb is the SI unit of charge and charge is a scalar. So here's our first concept of quantities ends here. Quantities are the reasons why there are vectors, and vectors is our concept to learn. So to understand vector, we need to understand why was vector first invented. What is the purpose of vectors? What does it mean? What is the definition of vector? A vector means simply quantities which have magnitude as well as direction. Anything which have magnitude and direction will be classified as vectors. Now we will learn about representation of vectors. Geometrically, a vector is represented as this. Geometrically, a vector is represented by a direct line segment. For example, A equals AB. Now we will learn about how we represent vectors. On writing wordly, we'll write just letters. A equals AB is AB is a vector. If you need to say or if you need to write, just write AB like this. Now what next? Here, A is called the initial point and B is called the terminal point. A is called the initial point and B is called terminal point. A is the starting point and B is the ending point. In compass, when we say initial point and terminal point. If you want to represent direction with it, well, it's not compulsory, but can be written like this. Representation with direction, it can be written as AB or AB slash. Well, it's not necessary, you can just write AB or AB with arrow. Simple. They can also be denoted by small letters with arrow above it. They can also be denoted as they can also vector, etc. etc. Now we will represent a vector on a plane. It's just an arrow. So you can call this AB vector or A vector, whatever you want to say. Now let's talk about this figure. What is this figure actually? Geometrical representation. Here in the figure, let's talk about things about in this figure. A equals AB. Yes, yeah, there's nothing problem in that. Magnitude is expressed as modulus A. Magnitude is expressed as A mod equals AB equals AB, which can be written in our bracket distance between initial and terminal point. Distance between initial and terminal point. So let's recap. A vector can be represented simply as just combination of two letters, A equals AB, where A is called the initial point and B is the terminal point, like this, A initial, B terminal. They can also be represented as small letters like A vector, V vector, C vector, whatever you want to say. An example of geometrical representation is here. To represent magnitude, what is magnitude? We just write A mod, which comes AB mod, which comes AB, and AB is distance between the initial point and terminal point. This is how representation of vectors is one of the easiest topics in learning basics of vectors. Here it ends. There are 2 points to remember we will learn in next slide. First one, the magnitude of a vector is always known non-negative real number, non-negative. Simple. Magnitude can never be negative. If your magnitude is negative, it means you have something wrong in your question, something wrong in your preparation. Second, there are 3 characteristics of every vector. characteristic is a length. For example, let me draw a vector. What is the length of a vector? The length of AB will be denoted by AB naught. It simply is magnitude. The length of AB vector will be denoted mod AB or just AB. Simply. Then comes support. Support of a vector. There's always a vector which is unlimited in length. Every vector is just a fragment of that unlimited vector, and that's what you call a support. The line of unlimited length of which AB is a segment. And last and not least, sense. What is a sense? The sense of AB is from A to B and that of BA is from B to A. The sense of a directed line segment is from its initial point to terminal point. In easy word sense is direction. The sense of AB vector is from A to B, whereas BA vector is from B to A. The sense of a directed line segment is from its initial point to terminal point. The sense of a directed line segment is from its initial point to terminal point. It means A vector is not equal to B A vector. These three, length, support, and sense, will be very important in understanding types of vectors. So please be very careful in understanding these topics. Length is denoted as AB mod or AB. Length is basically magnitude. Support is a segment of an unlimited length of vector, and then sense is basically direction. AB vector is not equals b vector because their directions are different, and how can they be equal? That's what sense is. These three are very important in understanding next topic, which is types of vector, in which these three characteristics will be used very often. So thanks for watching. Please like and subscribe if you want, and our next video will be dropping soon on this topic. So thanks.